Hi, in this video lecture, we're going to solve a commonly asked interview question based on linked list, which is to reverse a linked list. In the previous session, we've already solved a similar problem where we tried to print the elements of a linked list in the reverse order. But here, we are not just supposed to print the elements of the linked list in reverse order. We need to modify the links of the nodes in such a way that the list is completely reversed. For example, like if we have the list like 1, 2, and 3, right? And my head pointer points to first node, the next pointer of 1 points to second node, next pointer of 2 points to third node, the next pointer of 3 points nowhere, which is to say that it has null. So I need to change that in such a way that my head pointer points to the last node, which is 3. The next pointer of 3 should point to 2. The next pointer of 2 should point to 1. And the next pointer of 1 should have null value. Okay, fine. Now, this question is asked in various platforms. Like we are basically using HackerRank. And then you can also see that the similar question is also asked in Lead Code and many other platforms like HackerEarth, CodeChef, and every other platforms. It's a very commonly asked question. The only thing which differs is what is the name of the function, what is the name of the structure. Okay, so we are basically trying to solve this based on the interface of HackerRank, wherein there is a function called as reverse, and I just need to fill in the body part of that, and this particular function will be called from the main, and the code for reading the elements of the list as well as printing the elements of the list is already written inside the main. Our job is only to write the code for the reverse. Fine. Now, I will basically use a platform called as Python Tutor, where I have already written the code for inserting the element at the tail. That is one after the other. Okay, I do have elements out here, 1, 2, 3. And you can just observe the head pointer points to 1, and the next pointer of head points to 2, and the next pointer of 2 points to 3, and the next pointer of 3 basically has null. So I would like to do the job of reversing. So when I say reverse here, what exactly are we supposed to do out here is, see, the first node's pointer, which is as of now pointing to the second node, this should have the value null because that should turn out to be the last node. Okay, but remember, if I just change this to null, then I will lose a link to the second node. So I need to set this to null after, okay, doing the required changes so that I don't lose the link for the second node, right? And the same way, the link of the second node, okay, which is 2, which is as of now pointing third node, that should refer back to the first node. Okay, so this one, it is as of now pointing to 0E0, which is basically my third node out here. But instead, it should point to the first node. The first node has an address like hexadecimal value 54,020,40, which is this address, what you can see. Okay, which is the first node one, right? Head is basically pointing to the first node. So the link of the second node should point to head. The same way, the third node in this particular case, which is my last node, now this one should point to second node. What is my second node's address? Ending with 2090. So it's like 0x54,020,90. Okay, so this is what the changes what we need to do. And finally, my head pointer should point to this node, meaning the address which should be stored in the head out here is 0x, the last node is 54,020,0E0. Okay, so this one, whatever is here, this one should be stored here. Fine. So let us try to see how do we basically solve this particular problem out here. I've already written the code for reversing, wherein in case if the list is empty, even after you reverse, it will be empty because they've already specified a condition. In both the cases, like in this particular case, they've also given the case where if the list is empty, it should be the final result should also be empty. The same case, even here also, they have basically mentioned that, okay, if the list could be empty, it is basically trying to say the head pointer given may be null, meaning that the initial list is empty, right? So I have considered that particular case out here telling that, okay, in case if my list is empty, so I don't need to do anything. I just need to return back null. But in case if it is not empty, what I need to do it is I require 3 pointers. Okay, there's something called as previous pointer, current pointer, next. They are just variables. So initially previous will have the value null, meaning pointing nowhere. Current will point to the first node and next will point to the second node, right? So previous is null. Okay, so we need to concentrate on previous, current, and the next out here, right? I'll just try to remove this one, which is not required for us. Okay, so what I should do out here is, as of now, I have a pointer which is pointed to my first node. I also have a pointer pointing to second node. Okay, why is this pointer required is because now I will be changing this portion. I'll be changing this portion. If I change this, I should not lose the link for the remaining nodes. For that purpose, I have a pointer which is pointing to the second node, right? Now, what should I set to? I need to set this to a value which is present in the previous. What is the previous of this node? There is no node out there, right? Okay, so I need to take this value null and put it in this section. So here, what I'm trying to do out here is, I'm trying to say now that the next portion of current should point to previous, right? So here you can just observe, and okay, I have basically said next equal to current of next, which is same out here. Current of next equal to previous. You can just observe this portion here carefully. It is set to null. So it is as if like this one is pointing to the previous node of this. Since there is no previous node out here, it is basically null. Now, after this, okay, what I should do out here is I need to, okay, like this is done, right? So I need to bring the previous to this one now. I need to bring the previous now. Now my previous will point to the first node. And my current should point to second node. And after that, the next should point to the third node now. Okay, next is pointing to the third node, right? Now again, I should repeat the same operation. What should I do? I need to modify this portion. I need to store the address of the first node, and the address of first node is presently stored in the previous. So I will just try to say that my current node, where is my current pointing to this node's next portion should point to wherever previous is pointing. Previous is pointing to the first node out here. So I'm trying to make the link of this point to this. So you can just observe it's changed. So you can just see 2's next portion is pointing to 1. Perfect. Now, okay, once you set this link, you bring the previous here, you bring the current here, and you move the next to the next node, right? So you bring the previous to the second node, you move the current to the third node, and then you move the next to after third node. What is the after third node? It's null. So you said that. Fine. Now, once, okay, you come down here, again the same process. This portion I need to modify the link of this particular node. I need to set it to the second node out here, which is ending with 02090. So you can just see. After that, I'll try to bring the previous to this, and then current goes to null. Now, once current goes to null, it means that, okay, fine, you are done with all the nodes. Okay. So once you're done now remember this last node is the head now, like it should be the first now. So which pointer is pointing out here? Remember, current has already gone to null, next has already gone to null. My previous is basically pointing to the last node. So I need to return this previous. So when I try to return out here, so you can just observe that it is pointing to 1, and when you try to come out, you can just observe whatever it is returned. I'm just collecting it here. So you can just observe the link of 3 is pointing to 2, and the link of 2 is pointing to 1. So I have done this particular code. Now what I'll try to do it is I'll try to copy this code, whatever I've written here. And since I've basically considered the structure of whatever is specified in HackerRank, I will try to do the pasting in HackerRank first. The function name as well as the parameter list. Okay, the parameter list out here, I have used head out here because head term makes more sense when compared to ls. So I'm just trying to modify the parameter list out here to head. So you can just see, okay, all the errors are removed. Now I'll try to compile this particular program. I'll try to compile this. and see it is passing the sample test cases. Now I'd like to submit this particular problem out here. Same. It should pass all the test cases now. In some of the test cases, the list will be empty. In some of the test cases, the list will have some elements. Now, if we have to solve the same problem as per lead code, the logic of the code remains the same. Whatever I've copy pasted in HackerRank, the same thing I'll try to copy paste here. But only thing out here is the parameter name head. Okay, it is by default head here, not to worry. The function name is reverse list, and that is called from the main function. I don't need to call that. Only thing is the name of the structure here is different. The name of the structure is struct list node. See, in C, there was already in HackerRank, there was a type definition. There was a type definition for this. That's the reason why there was no need for us to use the struct keyword repeatedly. Okay. But here they have not used type def. If you want, you can basically use a type def and give this particular name, right? So then you can just keep the same code type def. What is the existing type? My existing type is this. And what is the new name you want to give? You want to give this particular thing as a new name. You can just use this. Okay. And let's try to run this. So wherever you're using singly linked list node, that will be internally treated as struct list node. Okay. Or the other way, what you can do it is you can just try to change this to struct list node, and struct list node out here. So then it should work fine perfectly. So I have run and executed the sample test cases. You can just observe, okay, all the three like empty list with 2 elements, with more than 2 elements, everything is done. So I'd like to submit this particular problem out here. And you can just observe that it has passed all the test cases. Fine. Okay. Thank you.